Hello and welcome to our second lesson this week on circle theorems. So this is 20.4 and it is the alternate segment theorem. So first of all, have a go at the do now question on the screen, pause the video, have a go and resume playing when you want to go through the question. So Q and R are points on a circle, so here and here, and we have centre O. PQ and PR are tangents to the circle. Now hopefully from last lesson you've remembered that if we have two tangents that come out from a circle and meet at an external point, then these are equal to each other. So these lengths are equal, and I'm just going to pop on lines just to represent that. Also, remember that the point of contact with the tangent to the centre of the circle is always the radius, and it's always perpendicular. So I'm going to draw the two radii in, OQ and OR, and also use the fact that the radius meets the tangent at 90 degrees. Excuse the shapes I've drawn on, they're slightly out, but these are supposed to represent the radius and the tangent being at 90 degrees to each other. So you can either use the fact then that the angles in a quadrilateral add up to 360, so 90 plus 90 plus 44 subtracted from 360 will work out this angle here, as it wants me to work out the angle of POR, and then you would half it, or you can just use the triangle straight away. So 90 plus half of the 44 is 22, because remember these will be symmetrical. Subtracted from 180 will give you 68 degrees. So let's just have a recap of all the circle theorems we've looked at so far. So the angle in a semicircle is always 90 degrees. Angles at the circumference and in the same segment are always equal to each other. Make sure they always come from the same 2 points. The angle at the centre, so this angle here, is always double the angle at the circumference. The opposite angles of a cyclic quadrilateral add up to 180 degrees. And the two from last lesson really that I want you to remember are that the angle between a radius and a tangent is always 90 degrees, and that from any 2 points when you draw two tangents they always meet, and these two values here are always equal. Now remember last lesson we did also look at if you have a chord and a radius, that the radius always bisects that chord, and it's just something to look out for in circle theorem questions. So the last circle theorem we need to go through then, and probably one of the most important, is the alternate segment theorem, and it's this one here. So let's just talk about it further. So our success criteria for today, our bronze objective, just as last lesson, is to recall and use the previous circle theorems. Our silver objective is to know and apply the alternate segment theorem. And if you're feeling brave and want to look at some more questions, we can look at the formal proofs as well. So what is an alternate segment theorem then? So this is the typical type of question. We have a circle with points A, B and C on the circumference, and the centre is always labelled as O. So remember, a segment is a piece of the circle that is enclosed by a chord and the remaining circumference. So this is a segment here, this is a segment here, and this is a segment here. So this triangle makes 3 segments within the circle. So the segment containing angle BAC, so angle BAC, B to A to C, is this angle here. So this angle here is called the alternate segment to over here, because here is the chord that we're looking at and it splits this circle in two. So the angle between the tangent and this triangle here is in the alternate segment to the angle within the triangle here. So it's this angle here that is equal to this one here. And alternatively, we could look at the angle between this part of the tangent and the triangle. So we could look at this angle here. So this would then be equal to it in the alternate segment. And it's just about spotting and noticing this within the circle. So if I go back to here, so here is the last circle theorem. So here is the tangent, here is the triangle within the circle. So this orange angle here is in an alternate segment to this angle within the triangle, because this chord splits the two segments. So it's this angle here is the same as here. Alternatively, we could look at this angle between the tangent and the triangle, and it would be equal to the angle in the opposite segment here. So the two green angles are the same as well. And as we look at more questions, or as we look at examples and questions, you will find it easier to spot as we go along. So don't worry about it too much. Let's have a look at this then. So in the diagram, find the size of angle ATS. So A to T to S, it wants this angle here between the tangent and this side of the triangle. And for part B, it wants angle TSR. T to S to R would be this angle here. Remember, using correct notation, that the letter in the centre of the three letters is the angle that kind of we're looking for. So angle ATS then, so hopefully you can spot this angle here. Here's the chord that splits the triangle. So here, this is equal to this angle here by the alternate segment theorem. So angle ATS is 80, so this is the same as this one here. Then angle T to S to R, we can then find that one. So that is in the alternate segment to that 70. So it's kind of in the opposite. So the furthest angle in the triangle is equal to the angle in the opposite segment, the alternate segment between the tangent and the triangle. So that one was 70 degrees. So the alternate segment theorem is really important, and it's probably the hardest to remember, and a particular favourite in certainly in intermediate and senior maths challenges, and also in the higher exam paper towards the end. This is the one that they like to ask, and it is definitely grade 8 question just by being able to recognise and find the angles. So let's have a look again. So here we've got the circle. Here we've got the tangent, which meets the circle at one point of contact, and we have a chord coming from it. So the angle between the tangent and chord we've just labelled as the Greek letter theta. So if then we create a triangle, so here's the chord, the orange here is the alternate segment, and it's the angle within the triangle that is in that alternate segment that is equal to it. So this angle here is equal to this one. Similarly, this angle here would be equal to this one, as that would be in the opposite segment to this part here. So let's check your understanding then, if you want to pause the video and have a go at this question. So we're trying to find angle Z. Hopefully you spot that the angle between the tangent and the triangle here is 52, will mean that this one is the alternate angle, so this would be 52 degrees here. Then you're using the fact that angles in a triangle add up to 180, so 52 plus 70 subtracted from 180, hopefully you got 58 degrees. Notice these questions always say they're not drawn to scale or not drawn accurately, because they don't want you to use a protractor. They're wanting you to recognise and use the circle theorems. Pause the video and you could have a go at this question here. So first one wants angle ABC, so A to B to C, so it's this angle here. So hopefully you are using that opposite angles of a cyclic quadrilateral should add up to 180. They're using the word supplementary here. It's just the same. Opposite angles add up to 180. So 180 subtract 68 gives us 112 degrees. Next one, it wants angle AOC, so A to O to C. Hopefully you're using that the angle at the centre is double the angle at the circumference, so 68 multiplied by 2 would give us 136 degrees. Lastly, it wants us to work out angle CAE. Well, hopefully you're recognising straight away that's between the tangent and the triangle. So here's the triangle. It's just slightly more confusing because we've got more information on here, but hopefully you're recognising this is the alternate segment theorem, and this is going to be equal to the opposite, the alternate angle over here. So it's going to be 68 degrees, and we just state by the alternate segment theorem. Pause the video and have a go at these 3 questions. So question number 1, so X, hopefully you're noticing and recognising now. So the angle here between the tangent and this chord within the triangle, so this is 65. Here's the opposite side of the chord, so this is the alternate segment, and it's the X, it's the opposite one here. So hopefully you're recognising that X is 65. Then generally we use that angles in a triangle add up to 180. So 65 plus 55 subtracted from 180 gives you 66 degrees. Question number 2. So hopefully you're spotting that here we have the tangent with the chord. So this 70 degrees by the alternate segment theorem will be equal to this angle here. So here will be 70. And then we've got an isosceles triangle. So if we take the 70 away from the 180, which is the angles in the triangle, would leave us with splitting the 110 remaining between X and this angle here. So X must be 55 degrees. Then hopefully you're spotting that we've got a cyclic quadrilateral also, and we know that the opposite angles of a cyclic quadrilateral add up to 180, so 180 subtract 55 will give us that Y is 125 degrees. Now for question number 3, this was a little bit naughty because I don't really think we need the alternate segment theorem here. If we were to draw this line in here, then we would have an isosceles triangle. So we've got an isosceles triangle, and we also know that the angle at the centre is double the angle at the circumference. So within this isosceles triangle, we'd have that this angle here was 98. And then we're just using the fact we've got an isosceles triangle, so 180 subtract 98 leaves me with 82. Divided between these would give me that X was 41 degrees. So now hopefully you will be able to recognise the alternate segment theorem. These certainly are just basic recognising and then working out the angles, but also you will need to mix it in with other circle theorems that we've done. So my suggestion now is you could work through some of the questions. I've only put on questions 1, 2 and 3. There are more in exercise 20F. It's in the folder of work for this week, so please feel free to print it off if you want a little bit more challenge. But at this moment in time, I'm just wanting you to recognise the alternate segment theorem and work through basic questions. So you, by all means, have a go at these ones, or alternatively, you can go and finish off the Hegarty tasks for this week. Good luck.